Okay, the title of your notes page is Solving Multi-Step Equations. Solving multi-step equations. So multi-step equations are equations that take more than just adding or subtracting and then multiplying and dividing. Okay, so we're going to have to do something extra before we can get to those two-step equations like we've been practicing. There are 3 steps. Step 1. Is to simplify both sides of the equation. Simplify both sides of the equation. So that is exactly what we just did. If we see parentheses and we have a term outside of those parentheses, we're going to distribute. If we have terms that can be combined, we're going to do that. Okay, so just like we did in our bell work, we're going to look at both sides of our equations and make sure that they're in simplest form. So here, if we had 3x plus 8x on one side of our equation, we would put it together to make our equation simpler to solve. If we had a 5 outside of the parentheses with a 3x and a 4 on the inside, we would distribute to make our equation simpler before solving. So we're going to simplify both sides, okay? We may have to simplify one side, we may have to simplify the left, we may have to simplify the right, or we may have to simplify both. But we're simplifying our equation before we do anything, both sides. Then, we're going to make sure all variables are on one side of the equation. It does not matter which side. All of our variables could be on the left. All of them could be on the right. It does not matter. But we can't solve an equation until our variables are on the same side. If they're not on the same side, we're going to move them. And we'll talk later about how to decide which side to put them on. But you could do it either way. Sometimes it's just simpler to move one over the other. So we're going to simplify both sides by either distributing or combining like terms, if we can, if we need to. And then we're going to make sure all variables are on the same side, if we need to. Okay? Step 3. Is to solve the equation using inverse operations, just like we talked about yesterday. So after we've simplified the equation and put all the variables on the same side, then we're going to see something that looks familiar, either a 1 or 2 step equation, and that's when we can start adding or subtracting our constants and then multiplying or dividing our coefficients, okay? So we need to get to the point where we can recognize when we're ready for this. All right? Okay, I said we're going to do 4 examples. Example number 1. 3 times x plus 4 is equal to 36. 3 times x plus 4 is equal to 36. So the first thing we're going to do is simplify both sides of the equation. So I'm going to look at let's go ahead and put our line. So I know where my equation is split up when I'm saying both sides. Let's look at the left. Is there anything we can do to the left to simplify this side of the equation? Yeah. It's one of the 2 up here.
You're going to combine like to...
Not yet. Distribute. Okay, if we can. We have parentheses and we have a number on the outside. So we're going to distribute. All right? 3 times x, or 3 times 1x, is 3x. 3 times 4 is 12. This is an addition sign, so I'm going to keep it as an addition sign. Okay, so now our left side has no like terms, no distributing. It's as simple as it can be. Okay? Our right side clearly is as simple as it can be because it's just a number. So now we can do step 3, which is solve using inverse operations. So I'm going to subtract 12 from both sides because I always start with my addition or subtraction of my constant. Those are going to cancel. I'm left with 3x on the left. 36 minus 12 is 24 on the right. Okay? And then I have a coefficient, so my next step is to divide both sides by 3 and get x is equal to 8. So in this case, I started by distributing and then I was able to solve. Make sure you're doing every step with me because these are going to be our examples to serve for our assignments. So if you need to refer back, you want all the steps. All right. Number 2. 6x plus 2x minus 4 is equal to 28. 6x plus 2x minus 4 is equal to 28. Okay. We're going to draw our line so we can look at both sides of our equal sign. Looking at the left, I'm going to look to see if I can simplify both sides of the equation. So I'm going to look at the left side and see if there's anything to simplify. Is there anything I can simplify on the left? Yes. I can combine 6x and 2x. So I'm going to do that. What is 6 plus 2? 8x minus 4 equals 28. Is there anything else I can simplify on the left? No. Is there anything I can simplify on the right? No. Now, I forgot this step last time. Make sure all variables are on one side. Is that true?
No.
Yeah, we have an x over here. We have 8 x's over here. We have no x's over here. Okay? We are going to now solve using inverse operations. So I'm going to add 4 to both sides to undo this subtraction of 4 or negative 4. On this side I'm left with 8x. On this side I'm left with 32. I now have a coefficient of 8, so I'm going to divide by 8 on both sides. X is equal to 4. All right. 2 more examples. Number 3. 10.2 equals 0.7x plus 0.5x plus 3. $10.2 equals 0.7x plus 0.5x plus 3. Now, this is where I'm going to make sure I have a calculator. If you don't have one right now, just wait. You can get one in a minute. I will do it up here. So, I'm going to start by drawing my line down my equal sign, splitting my equation in half. I'm going to cover up one side. Is my left side as simple as it can be?
No.
My left side. Yes, it's just a number. Okay, what about my right side?
You can do math.
Okay, I can combine like terms. So I'm going to do 0.7 plus 0.5, or 7/10 plus 5/10. Okay, so here I have 10.2 equals 1.2x plus 3. All I did was carry this down from the left side. Is there anything else I can do on the right side?
Nope.
No. I don't have variables on both sides, so I am good to solve. So I'm going to come over here because this is where my variable is. I'm going to subtract my 3. Just because things are out of order doesn't mean we're going to solve it any differently. So I have an added 3, so I'm going to subtract it from both sides. Over here, I'm left with 1 and 2/10 x. On the left, I have 10 and 2/10 minus 3. Since I didn't do a good job of lining that up, I'm going to use my calculator and make sure I get the right answer because my 3 should be underneath my 10. So I have 7.2. Okay? My last step is to undo this 1.2 by dividing both sides by 1.2. 7 and 2/10 divided by 1 and 2/10 is equal to 6. There is no reason to stress out about the fact that there are decimals in the problem. Okay? Use your calculator. We have one more. -2 is equal to -2 times 3x plus 4 in parentheses minus 6. -2 is equal to -2 times 3x plus 4 in parentheses minus 6. There's a lot going on in this problem, so we're going to take it one step at a time. Our left side is good, it just has a -2. Our right side, we're going to simplify. So we're not solving anything yet, we're just simplifying. What's the first thing we need to do? Distribute our -2. So I'm going to put -2 times 3x, which is -6x. If you still need to use a calculator to make sure you get your negatives right, do it. -2 times 3x is -6x. -2 times 4 is -8. I don't distribute to the 6 because it's outside the parentheses. Let's bring down our left side so we don't forget about it. Okay, now am I ready to solve?
Yes.
No, because I still have 2 like terms that I can combine. So I'm going to keep my -6x, but I'm going to combine